All right, here we are, guys. Tuesday. Sun's shining out there. It looks like it's going to be cold, but a sunny day today. Hopefully not as windy. Um, we've been talking about force and motion and moving through these ideas, and really, it's a physics unit, but it's really about how energy transfers. So we're really starting to dig into that a little bit more. And in order to understand how energy transfers, you have to understand what an energy system is. And so I'm going to give you some examples, but I think by the end of this short little bit here, you'll be able to figure out that there are multiple systems, and you can identify how energy is transferred within those systems really well. And that's actually one of your sort of your essential and ultimate goals, is to be able to describe how does energy move within a system. All right, so the first thing I want to do is, that's our target. We're still working. Now, remember, the targets aren't as individual each day like they were in class. No, our targets are more so a big thing we're building at. So we're working towards constructing an explanation based on a question I will ask probably next week, and then you'll start to construct an explanation and provide your evidence and collect that. So that's what we're working towards. Here's your task list for today. You're going to preview this slideshow. You're doing a good job with that already. Watch my video explanation. You're also doing that already. You're going to go into PhET Systems Simulator, and I'll go through that a second for you, then answer a question that I have for you. All right, so let's go ahead and get you out of there. And I want to take you over to this. And what I'd like you to do first is I want you to get out your piece of paper with some notes, or your notebook. And if if you lost the page you had before where you took some force and motion notes, that's okay. Now we're working on energy transfer, so you can start a new page or go ahead and just add to the one you had previously. If you need to pause it right now, go ahead and pause the video so that you can go ahead and get your notebook or whatever sheet you have. All right, so we're going to talk about several things. We're going to add more to this list as well. And I just think it's really important that we clearly define what things are, because some of us are very like black and white thinkers in terms of, there's no vague or sketchy area. It's just, it is what it is. So what is energy? Well, energy is always defined as the ability to do work, right? So easy breezy definition. If I think of that, I think of, sometimes like a good example would be last night. I'm not sleeping well. I got something going on with my arm, so it's keeping me up in the middle of the night. So I wake up and I feel like I just don't have the energy. I feel like I don't have as much ability to do work as I would normally have. So energy is defined as the ability to do work. Oh, there's our little bad image thing that likes to show up 100 times. Wish I knew what that was. All right, well, that fun game's over. So energy is defined as the ability to do work. So no matter what we're looking at, wherever there's a transfer of energy within a system, or from system to system, that always has to do with the ability to do work. Okay. Sorry. So let's talk about potential energy then. Potential energy, I love that you guys were using yesterday. You were using words like built up energy or energy that is collected or things like that. So potential energy is a specific energy that really has to do with an object or objects or structure. And it's energy, and it's associated means linked to, right? It's energy associated with an object's shape or position. So if you think about how, this should be possessive, right? Because we're talking about what it actually belongs to. If you think about a rubber band, and you stretch a rubber band back, you're changing the shape of the rubber band, and that rubber band wants to go back to its original shape. So you end up with something that has built up potential energy. If you watch the video of me shooting my bow, I build potential energy when I change the shape of that bow. And then it's kinetic energy when I release it. All right, so that brings us to the next one. Kinetic energy is always energy associated with motion. Now this is interesting because when we talk about, there are other types of energy as well. So potential energy, I draw the bow back, change the shape of the bow. It wants to go back to its original shape. That's the potential energy that's been built up, and not created because I converted it from my body, from my muscles. I transferred that energy to that bow and changed its shape, and now it wants to transfer that energy by going back to its original form and releasing the arrow. But energy associated with motion, so I'm going to add in here too, because there are other kinds of energy you're used to. You've heard of light energy, you know about that. We use that on a daily basis. You know about thermal energy. We've talked about that. So let's just mention thermal in here. And actually, we can add that to this. We can say thermal energy is also kinetic energy. And that's, there we go, because thermal energy has to do with the movement of atoms and molecules. And you know that from our chemistry unit. The more thermal energy something that's transferred to atoms and molecules, the more those atoms and molecules move. So thermal energy is actually also kinetic energy, energy associated with movement. So far we've defined energy, potential energy, kinetic energy. Conversion, another thing that could be thought of. Conversion is really the transfer of energy from one type to another. And it could be, it really could be one type to another type, kinetic to kinetic. I mean, you could have a bowling ball bump into another bowling ball, and you've got the energy of motion transferring to the energy of motion. So it's just the transfer of energy from one type to another. And that's really what we're looking at is energies within the system and how they transfer. There is another one. I'm going to add up here. Like I said, we also have light and thermal energy. Another one I'm going to add just because it's important with this so that you understand it is chemical energy. So chemical energy is energy that is stored in the bonds of molecules. So if you really think, of how, think of fire. Let's take fire. So fire is combustion. That's the name of that chemical reaction. So when we get that reaction going, this thing we call fire, the energy that is released, the light energy and the thermal energy, that was stored in the bonds of the molecules that you're using for fuel, and within the the oxygen molecules. So when those bonds break, that's where energy comes out. So energy is stored in the bonds of molecules. Now wait a minute. If we're talking about energy that has the ability, or that's stored up and has the ability to be released, I'm going to have to add to this that this is also potential energy. This is also energy that has the potential to be converted into kinetic energy or light energy or thermal energy, such as with fire. All right. So then energy within the system, the last thing, I want you to think roller coaster. Energy is within the system is just energy that is transferred, and really the word, I think, sorry, I can't talk and type, transferred from one form to another, and really the word, I think, is converted. When we talk about conversions, it's really converted from one form to another. So if you think about a roller coaster, man, you're thinking about potential energy, kinetic energy, potential energy, kinetic energy, right? We're not changing the shape of the coaster, the car, or the people, or the tracks. We're just changing its position. And from that, we're getting all sorts of acceleration. So energy within a system, the reason I think roller coaster, that's kind of within one object or a collection of objects. So roller coaster would be a great example of a system. The energy transfer within there. Now, of course, we're using electrical energy to push the roller coaster up on that initial hill, and then that energy, that's building potential energy by changing its position further away from the Earth's surface and allowing gravity to have a little bit more work on it once it gets there. And then that transfers to kinetic energy like crazy, and it's fun. All right, so make sure you have these definitions on a doc or on a notebook paper. Creating your own doc would be a good idea because I want you to be able to go back and take a look at these. All right, the next thing I want to show you is some photos, or some images rather, of just some conversion stuff. So let's take a look at this guy. And I think I can, okay, so too much, there we go. Let's take a look at this. Here's some energy conversion or some energy transfer. So if we look, we have up here you got an apple, right? And we just said, and so now I hope these pieces are starting to come together for you, even just as a biological human being. Like, how do you get your energy? Well, the energy is stored in the molecules of the food that you eat. And of course, that energy, was transferred from radiant energy from the sun at one point, from light energy, that the plants did chemical reactions called photosynthesis, and they stored that energy in their bonds. So there's potential energy in the food, in the bonds of the molecules, and then that's also called chemical energy. So you eat that food, chemical energy, and you convert that eventually into what's called mechanical. And we'll talk about that. Actually, let's go back and do that right now to our doc. I want to add mechanical energy. This is important. Let me put, there you go. Mechanical energy is the sum of potential and kinetic energy. So, whoops, it bumped me to the next page, didn't it? Yeah, so potential energy is the sum of the potential, or I'm sorry, mechanical is the sum of the potential and the kinetic energy. So you end up with a lot of things, adding together there. All right, so back to this. So mechanical energy, obviously, if you eat this, chemical energy is potential energy. Now that's stored in the cells of your body and your muscles and so forth. And then you can use that energy to go ahead and pedal that bike, and you transfer. So the mechanical energy they're talking about in this image is both potential and kinetic, as he changes the position of the pedals, and he's pushing down on those, he's converting that to potential kinetic, which in the sum of is called mechanical. Well, then we have electrical energy, and that's converted to light energy. We have light energy that plants use photosynthesis and convert it to chemical energy. They store it in the bonds. And then we have chemical energy, again, through those bonds, we end up with, when that's released, we can convert that to light energy, chemical energy in the fuel we put in automobiles through combustion, right? So there we have, we're breaking the bonds, we're releasing thermal energy and probably light energy too in that combustion, but we don't really care about that. The thermal energy expands the gases in the cylinders of the engine, makes that engine turn and move, and eventually we transfer all of that stuff to mechanical and allow those tires to spin, and then of course electrical energy transferred to thermal energy so you can make toast. So listen, this first video is about done. I'm going to end it, and then I'm going to start a second one, so you'll have two videos to watch, just so I can describe the next two things. The next one's much shorter. And then you can go ahead and do a little bit of work today on your own and answer one question for me on this assignment.